on about was basically I talked about not doing these problems anymore because they were getting to take too long, and yeah, I mean, I just got other stuff to do. But then I got the problem right yesterday, so I was feeling pretty good, and so here we are today. And I already looked. This one's a medium, but it looks fun, so I guess we're gonna stick through it and see how it goes. And this problem is called Number of Islands, and the deal is given a 2D grid map of ones and zeros, land and water, we are going to count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands either horizontally or vertically. You may assume all four edges of the grid are surrounded by water. Okay, so this one sounded like a lot of fun, so I'm excited about that. But here, if we look at this one, the deal is the ones are land, so we can say, kind of just see with our eyeballs here, that all these ones are connected, so we've got one island. Down here, we've got some ones, and then here we have, three islands, and here it's kind of showing us that the diagonals do not count as being attached, so that is good to know. As for solving the problem, I mean, we are definitely looking at a graph problem. No doubt about that now. So that's kind of a relief to have a straightforward kind of thing going on. Now, graph problems do frequently fit nicely with dynamic solutions, so we might end up with some sort of dynamic problem. I'm not sure yet. Still kind of thinking it over. But just kind of from a human perspective, I've been kind of thinking, you know, how I kind of see the problem. And basically what my eyeballs kind of want to do is basically just start somewhere. And when I see an island, I want to kind of go out there and find the edges of it and kind of mark them. So I'm almost thinking about kind of starting from here and then growing to the left and down and right and whatever, every direction, and kind of marking every one of these guys that I see from any one of my nodes. And so that's cool. So I can kind of mark them as visited and basically tag them as part of this island. And then later, I can go and kind of move on. And if I've seen an item already, I can move on. So I only need to look at each element once, I believe. So I think this should be a pretty efficient algorithm. I'm going to kind of think that through here a little bit more using this example. So if we were kind of, I'll take it down here. Hopefully this is readable. Hello out there. We're trying to count the number of islands, which sounds like a pretty fun problem. So what I'm thinking about doing is basically starting at the first index, which in this case is a 1. Oh gosh, I left my dogs outside. Hang on. Let me figure out how to pause this thing. I'm going to be back in like 30 seconds. What was that? Sorry about that, guys. And we're back. Sorry about that. I forgot. I left my animals outside. Alright, where were we? So we're trying to find the islands. And we need to not double count and not do a bunch of extra work. So I was just kind of trying to figure out if the solution I had in mind was going to double count things. Ooh, sorry, I literally ran to the backyard to let the dogs in. They just started barking. Anyway, if you've done this problem already, I'm all about those spoilers, so let's talk about solutions. So we're just having fun, casual. What's up, Abdul? Excellent. I saw it was listed as a medium, so I got scared, but then it looked like a really highly visual problem, so I got excited. So we start at the first one, and let's say we choose to go up, right, down, left. So I'll check up. We got nothing. I'll tell you what, I'll go ahead and mark this as a letter A, first letter in the alphabet. And that'll kind of help me know. So I'll say current letter is A. We went up. We couldn't because we're at the end of the array and said we can treat that like water. So we go to the right. It's a 1, so we'll mark that as A. We go to the right again. And, or should I said, I should say we try to go up. We can't. We go to the right, and we can not. It's water, so we'll leave that as 0. And then we'll go back to our A, and we're going to do this recursively. And we will mark this next item here as an A because it's land. Then we'll come back here, and we'll go left, which we've already visited. So from here, we'll go down. We'll see this is an A. I'm kind of doing a couple things wrong here. I guess I need to decide whether they're going to go deep or wide first. I don't think it matters. So the question is, like, do I visit nodes, like, if I'm at this one, do I go up, right, down, left? Or do I do something more like straightforward? Okay, cool. That's exactly what I was thinking. All right, so with depth first, to be more like here, then here, then here, and here, and then here, and then we just keep going that direction. So yeah, I don't see any reason to prefer one over the other here. So we'll just do depth first. I was just going to try that out with paper. Depth first traversal. And I think that's going to be efficient. We're only going to look at each element basically once. So in this case, we'll go mark the first item as A because it's land. We can't go up. We can go to the right. So let's go right. It's a 1. Mark it as A. Go up. Can't. Go right. It's water. All right. We'll leave it as 0. And then we will go down. We see that's land, so it's connected. And then from here, we try to go right. Can't. We try to go down. We can't. So we go left, and we've got an A. We can't go up, right, but we can go down. So there we go. So we've completed an island. I have no other neighbors I can get to. And so then what I'll do is I'll basically just go to the next element in the array. I'll say that it's been visited. And so I'll have to basically track that somehow. You know, I don't have to necessarily label all of these. I just have to track them as visited. You know, I've looked at them once. Same thing for here. And there. So all the zeros are going to go easy. We basically just skip over them. And I'm choosing letters just for visualization, just to make it a little bit easier. When I get down to this one now, I'm going to go B. I'll see we've already visited up. Nothing to do there. We'll try to go right. It's 0. That's fine. We'll try to go down. That's 0. So we know we can stop. And so it's essentially like a depth first traversal, except the trick is that whenever I run out of items that are connected, I'm going to stop that path and then move on. So I only kind of move contiguously. And that's how I basically can keep track of which ones are separate islands. I can't just loop through the graph and keep going because I don't know if I like see this item and this item, if they're connected, unless I go back and check. So I think it's easy to just kind of build that up and keep track of how many of these we've seen at a time. And I think this will be good. How's the latency today, by the way? I think you got it worked out, right? Thanks to you, by the way. I got rid of the replay buffer of 20 seconds and then dropped another one from like 5 to 2 seconds. I guess I need to know. We're returning the number of islands. Start it at 0. You got a character grid. All right. Let's do I and J. Testing 1, 2. Guess we'll see. And it's kind of hard to measure it, but you know when it's wrong. Uh-oh. So I said that pretty much as fast as I saw it. It's going to be grid at eye length, sure. Now, how do we keep the items that have been visited? Still like 25 seconds? Really? Oh man, I'm sorry. Dang it. I really thought I got it. Yeah, I'm gonna have to do some Googling or something. Oh, man, that's a bummer. Alright, well, sorry. So we're gonna go over each item now. If it's land. And I'll set the character. I think we'll be doing this enough to make it worth it. Oh my god. Got some bad dogs. You guys lay down. Ooh, they hate the delivery guy. Let me tell you. I don't know if you can hear the load. Alright, hopefully I muted correctly. That was awful. I guess I got a delivery and the dogs acted like it's the end of the world. Happy Friday. Oh gosh, never get dogs. Never get dogs. I love them. I'm kidding. Alright, so character at grid. So what's the way to, I'm trying to think like the best way to actually store this. I kind of like the idea of doing, of like actually kind of having another copy of the whole grid here, but I don't know. I don't know how I'm going to do this yet. Maybe we'll just say kind of like a visited structure. And inside there we'll store the I and J as a key, so we can do quick lookups to see if we've visited the item in constant time. So it'll be really fast lookups that won't affect our runtime. Alright, so if, let's see, if visited at, what's the best way to do this? I guess IXJ. If visited at IXJ has a value, then we've already visited. So we can just keep on trucking. Otherwise, if, and I don't even need to get the character for that, I can just check to see if we've ever been here before. Then, if the character we're looking at, I don't like the word char. What's something better? Oh, was it loud? I'm so sorry. I thought I guess, yeah, they took me a second to shut off the mute. They're terrible dogs. Land type. Terrain. Sure. If terrain equals, we'll do 0 first. Then, should I mark it as visited? I kind of don't really care about terrain. I don't know. We'll skip it for now. Alright, so if terrain equals 0, we'll continue. Now if the terrain equals 1, that's the only other situation we have to worry about here. If if the terrain equals 1, then I haven't written this recursively. And I think that's okay. We'll just do another function here, and we'll have this be the recursive function, call it visit. And we'll pass it our visited list, I guess, and our I and our J. And we'll probably want to move this stuff in here. So I think we're just going to need that same kind of logic in there. So let's just move all this stuff up here to our little helper. Sure. There's too many different ways to write functions in JavaScript. For some reason, I just like the syntax, the defining it as an anonymous function, even though it has a named anonymous function. Anyway, so if it's visited, then here we can just return. We're done. If it's water, we can just return. We're done. If it's land, I don't need an else now. If it's land that we haven't visited before, then I'll go ahead and let this be a key. Visited at key equals what? Do I need to keep anything here? I haven't really thought much about what I'm going to return here. So let's think about when we visit. I'll pass in, we're going to do this for each node. We'll try to we'll call it maybe visit neighbors. And we'll pass it our visited list, visited map, as well as I and J. And what I just kind of want to know is, like, if you're an island or not. Does it make sense to have this return a 1 or a 0 if it's a new island? Let's see. Maybe I should just call this isNewIsland. That's a awkward function name, but it maps better to the result I ultimately want to get. So I can basically say for each item, if you're a new island, then island count ++, and that's it. I think I like that. Yeah, call visit from the main function only if, yeah, so I don't, yeah, you're right, I don't need to do that there. I mean, I do check it here, so it would be double checking. I think I might just leave it here for now, and I'll probably end up moving it up, but because I'm going to want to call this recursively. Say visited at key equals. What I'm trying to figure out is basically if I even care what this value is. If that's the case, I could just do a set. Well, I'm not totally sure yet, so I think I'm just going to leave this as a hash for now, and then we can revise it down to a set if needed. So if it's a new island, we'll mark visited as yes. And then we'll return is new island up from us. So we'll pass the same visited, and then I -1 and J. That's up. Yeah, I might have some weird stuff going on here. So I don't really so much want plus as I just want or. I don't think I'm doing this right. So this is up. This one will be right. This one is down. And this one is right. Nope, this is right. This is left. And I feel like I did something wrong here, but I think we'll figure it out pretty quick. JavaScript arrays are passed by reference. So it allows us to basically share the same grid. We'll not create a new copy of it. And same with the map that I'm passing in. Speaking of, I don't ever pass the grid in. That's kind of important. So that needs to go in here too. Okay. So if we've ever seen this node before, we quit. And we'll return false because that's fine. If it's water, also false. It's not a new island. We are doing ore, so if any of these is a new island, then we'll get it. And if it's new, we will mark it as seen so we don't hit it again. There's a couple other things I'm going to have to check here, but we'll come back to those in a second. And I'll basically say, like, if any of your neighbors are a new island, then we'll return true. And even that, you know, this is kind of a silly thing because I don't actually need to return those values. I already know true because I am a new island because we already checked to see if we're 0 and false. So we don't need these ors at all for any of these. Okay, so we're just gonna go spread out like that. Oh, you know what? And I said DFS, and this is a BFS algorithm, so it doesn't matter. It doesn't affect anything. It just, that's kind of how I was thinking about the problem, I guess. And in here, yeah, I know what you mean. It'll end up kind of checking that there. So we'll leave. A couple other things we need to check. For example, if I is less than 0 or I is greater than grid.length, greater than equal to grid.length, then that's a return. Or J is also invalid. Turn false. So we broke the edges. Is it DFS still? So I go into a new item. I go new island. You're right, it's DFS. And you come back in. It's new island. Okay. Good call. Good call. And then here we just need to return the island count. I think this is about it. So we got the right answer. First time, that's kind of scary. We'll try this one. Ew, I don't want to have to write that all. All right, fine. All right, I'm too lazy. Let's just see if we got lucky. Oh, no. So actually, this looks like the thing I was trying to type out. So I did something wrong here. An empty array corner case. Okay, so if they give us an empty array, then it should just return 0. will that happen here? I think empty array will work out here. It'll just return 0. I just ran it again just in case it was any different. So what should have happened here is we should have started here, and then it should have gone up, can't, right. It should have said fine. And then I wonder if I did something wrong in the way I expected the array to come in. It's an array of columns. I think it should work out either way. Alright, so we said right, it was fine. It tried to go right again. And then this time, it saw that right was not. Grid at I on an empty array. So I only I only look at grid at I in this loop. That's the only time I call is new island. So only if both of these are true. So I think that I don't call it. Let's try it though. You're basically talking about this, right? Should return 0. Okay, and if we did something even like that, then I should expect to also get a 0. Okay. So I think we're good there. I don't know. There's lots of things that I think I handle and then they come back and bite me. So I think what's happening here is that my DFS doesn't know when to stop. I think. So I come in here to an item and I say go up. It comes into this item, it sees that it's invalid, it should return false. Then it comes back into here and then it says go right. It's not visited. That's fine, but it is a 0. So it should return false. Okay, so this is false. Yeah, that should be fine. Then it should go down. Yeah, so all this looks good to me. So I think you know what I'm going to do. No, I'm going to debug. I don't want a console.log. I'm taking a stand. What is this one? Island count. Sure, islando. All right, and then sample input. There we go. So if I call console.log on num islands of this, and there we go. Oh, I forgot to set a breakpoint. Each array is a row, not a column. Does that matter if we're just only looking at I and J? Like, I guess that would make J the top one and I the other one. So I guess that really means, yeah, it doesn't mean that we're going up, right, down, or left. It would be twisted. I don't know. I guess it's going to make it harder to debug. So that's definitely worth it. We're about to debug here. It's going to be real hard to know what's going on if I've got this thing twisted. So if we take that out, just run on the default input. What's up, Vic? Did you get my email? 111101. Oh, I did get the wrong input here. Wrong answer. I minus 1 is up. Okay. And then j plus 1 is right. So if this maps to this right here, then I think we're good. Yeah. Oh, cool. So you got the answer? Awesome. Sorry, I know this is delayed. So today's problem is neat. It's a graph problem, recursive problem. It's kind of fun. We're hunting for islands. Let's see here. What breakpoint do I want to set? Hey, that's good. That was a really hard problem. Try running this thing. All right, so we got grid. So we're saying that 0x0 is visited because I just marked it as visited. Yep, 2D array. I'll show you what it looks like. Basically, we get an input like this that it's kind of like a map in a video game or something, like a 2D video game. And the ones are land and the zeros are water. And so we're trying to count the number of discrete islands. In this example, there's an island here in the top left. There's one kind of in the middle. And then there's another one on the bottom right. And we could treat the edges like they're water. But for some reason, I keep returning 1 for this sample. But the way we do it, the rough solution is basically we take a look at here and then we try to go in every direction. And so in this case, we go up, down, left, right. We see that as part of our island, so we mark it and count it, and then we move on. And then as we eventually realize we're surrounded by water, we move to the next item. And if we see what we've already visited it once, then we back out, and that's how we avoid double counting islands. So it should just run through all these other zeros and all the other items we've visited really fast until it gets down to here, which is net new. So it should return true. We should count that as a new island and it should move on. So maybe that's the way to debug it, is basically just kind of know, like, okay, we're looking at a key. So we're looking at 0, 0, which is land. So this is going to get counted. So that's looking good. And this is where it's going to go to each of its directions: up, right, down, left, and then ultimately return true. So now we came back around and we are looking at 0 times 1. So that's the second element. That's good. 0 times 2. That's good. And 0 times 2 here, though, I expected to see... I expected 0 by 2 to get a 0, so I didn't expect to hit this breakpoint. So that is interesting. So if I look here at my array, okay, here's the problem, I think. So these are strings, not numbers. So what it's saying is 0 by 2 is 1, and that's obviously not the case here, because I'm checking to see if it's equal, 0, and it's that triple equal sign is messing us up, because this is not a number 0, it's the letter 0. So, fun times. So now if we run this, we should see the key be 0 by 0, good. We look again, 0 by 1, good. Now I should not get to 0 by 2, I should skip it. Alright, we got 1 by 1, we're good. So now I'm going to erase these breakpoints, and we should see the right answer here. Oh, but I closed the window. Let's try this again. There we go. So that was a fun little diversion. So if we run this again. All right. We're going to submit. No, wrong answer. Okay. So this is one long island. And I think this should have worked. Let's see here, because it should have been able to go to the right. So j is 0. J is less than the length. That should be fine. So let's try debugging this one. Okay. Where do I want my breakpoints to be? So I'm expecting the answer 3 here. So we see we have one long array with 7 indexes in it. Oh, there they are. So the key is 0 by 0. And that's good. So our first island is right there. The next item is not an island, so we should mark it as visited. And then we should move on. Oh, this is funny. I'm not currently marking zeros as visited, but I think that's probably okay. That might be our problem though. Alright, so 0, 0. I'm just going to set one here since this is such a small data size. And we come back in here, we should see, let's actually do it there. -1 by 0, which should get returned false there. Okay. 0 by 1 should be water. So in this case, that was good. So it's skipped over it. 1 by 0. That's I equal to 1 and j equal to 0. Now that should be legit. So we should be able to see that one hit right here. Oops, I did something wrong. Yes, not diagonal, only vertical or the other one, horizontal. Okay, yeah, something messed up here. I'm not sure exactly what happened here. Let's run this again. So we look at 0 by 0, and it's an island. So if we come down to here, we should see terrain is 1. Okay, good. And we should return true. Okay. So now we're looking at -1 by 0, which is not part of our array. Because I is -1, it's less than 0. Okay. Now we're looking at 0 by 1. So if we look at our array, that should be valid. Because 0 is the first index and 1 should be a 0. So I'm going to actually step through this one. Check this out. I got a bug. I checked to see if I is less than 0 or greater than grid length. And then I check to see if j is less than 0 or greater than grid length. So that only works if it's a perfect square. I need to check the actual row I'm in. So let's try this again. Sure, we'll just run the whole thing. Now we got the right answer. Okay, so that was a typo. That was a bug. We still got the right answer we expected here. Now it's going to work. Wait, what? What now? Like how I act surprised as if this isn't like what it's like all the time. Alright, so we're looking here. Now, this is going to be the first one that we've looked at where the first item is not an island. So it should have just gone onto here and said, this is one island. Went to here. It's just said, this is another island. Go to here. This is another island. Okay. And so that's good. And I think that it also kind of affirms that we're doing the right thing here by not recording the item as visited if it's a 0. Hey, congratulations. I have a baby sister. She's not so much of a baby anymore, but that's awesome. Congratulations, man. Let's see here. What did I do wrong? So if we run this, what answer did we get? The answer 3, but we should have gotten 4. So we'll just do the same thing, I guess. Set a breakpoint. Oh, I already messed up. Set a breakpoint. 0 at 0 is water. So we should return down there. It's good. All right. And now we are looking for 0 by 1. I guess I could just step through. We haven't visited it. Okay. It is an island. So we mark it as visited. And then we check its neighbors to see if it's a big island. And these should all come back false. So I don't need to step back through those. Oh yeah, but it does. Ugh. Yeah, debugging recursive stuff, it gets weird. So now we're checking basically one of its neighbors, which doesn't exist. They'll return out of it. So I'll just skip over these other guys. I hit the wrong shortcut before. So we're saying that 1 by 0 is true, and that's good. Okay. So our island count goes to 1. So that was this first one here. We're going back in. And I was hitting the wrong shortcut key. So I kind of just want to see which ones it's counting. It's counting 1 by 2. Which is 1 by 2, but it didn't get this one. A pen tester? I'm not a fan of pen tests. Usually because I have to go fix up whatever they find. So this is going to go to 1, it's going to go to 2. I'm surprised we didn't see this one though. I don't know what happened there. That makes me think I've got like I and J in the wrong place. Yeah, look at this right here. I passed a 1 instead of an I. Typo. Alright, stop the whole shebang. This is it. Now if we run it. Man, fun times. Alright. The nice thing about doing this stuff like in an interview and a whiteboard is that they generally can't run it. So you get away with little mistakes like that. Yay! Oh my gosh, look at that though. What happened there? Beat 9%. Yeah, classic typo. I don't know, I like the solution though. We could definitely trim it up. To make it faster, we could probably, I don't know, we could check. We could probably add zeros visited. That would save us a little bit of math, not that much. Yep, 1 and I. I don't know. Because we could look at their answers and kind of see. if we look up in this distribution, like what do they do differently? Rows and columns. Oh yeah? Ended up with a different one? You have it in C++ share? Oh, look, they're doing, this is, okay, so they're doing a breadth first search here with the priority queue. Only changes everything to visited. This really doesn't look much different. It just, it does a, I guess by doing a priority queue, you avoid looking at some of the things over and over and over again. So I am visiting more nodes than I need to be. That's more recursive calls. And then they flip the bit to let it know it's been visited. Okay. So they didn't have to do a big map. They just kind of did it with one. Looks like the same grid that they're changing, right? Queue push. So yeah, that'll be more space and that'll be faster. And they do change the actual grid to let it know when they've modified something. Okay. What about super fast? Whoa. Alright, checking the boundaries, fine. They mark this item as 0. And they check the items near it. What does that mean? Goes back into the recursive function. If increment, which is the third argument and is optional. That's weird. I don't see them ever passing. Oh, they only pass it there. Okay. So they only increment the first time. Yeah, tired right now. We should do another problem. Yeah, I think I probably am going to be back on later, but I think I'm going to cap this one off here and call it done. And then let me know what you guys are interested in seeing, though, because I've got a weekend coming up talking about doing some coding on Apache Drill, which is surprisingly cool with Michael Outlaw this weekend. So we might do some pair programming on somewhere. And aside from that, I am thinking about doing some more challenges that are focused on the things I've been doing bad at. So I was thinking about doing a couple problems that are dynamic, like basically trying to find like the easiest dynamic problems on the internet, and just trying to kind of solve them and just practice on them. And awesome. I'll check out your C++ here. And so I'm thinking about just kind of doing some problems like that, just because I keep having a problem with these dynamic problems, and I want to. The reason I'm doing this is because I want to get so good I can do this stuff in my sleep. So I'm thinking about doing that. And I've got another open source project I want to do some coding on. So I don't know what I'll stream or what I'll just kind of do on the couch. All right, so looking at the code, you've got a vector of visited, cool, rather than a map. I like that. Set visited item is true as you go around. Okay. Okay, you got the edge case right there. I'll count. So you loop through. Oh, if it's 1 and it's not visited. Oh, that's slick. Okay, cool. That's a good way of doing it. I like that. I like that better than the way I did it. Basically, if you come upon new land and you haven't marked it as visited, then you record it. And then after you record it, go through and mark everything that's connected to it as visited. That just reads better to me. That makes more sense. Yeah, man, very nice. 90%? Dang, that's good. Very good. Yeah, man, that's awesome. Congratulations. All right, well, cool. Well, I'm going to take a little dinner break, and then I will either come back and stream or play video games. I don't know which yet. But I hope you all have a good Friday. And yeah, if you think about what you might want to see streaming, just drop a comment or something, or send me an email or Twitter, tweets, whatever.